So I already told you what is Poisson equation. Laplace in phi is F. Okay. So for electrostatics, it is charge density. For gravity, it is the mass density. If you noticed, for incompressible flows, we get this one is left hand side is pressure, the right hand side is divergence of the nonlinear term. Okay. So it also occurs in hydrodynamics. Okay. Anyway, so how to solve it? So let's apply the same logic. I discretize it like before, and so this equation I already derived. Okay, so this is this equation, left hand side. Right hand side is f I comma j. Okay, so what are the unknowns? Unknowns are these phi's. So you're writing as a matrix. A will be the same matrix which I discussed, which will involve 1, -4, 1, 1, -4, 1, and 1, 1. Okay, and these are knowns, phi ij's, and these are RHS, the source. These are called source term, source, like charge, mass. So source is the right hand side. So I can solve for this. So this will be basically A inverse, no? The A inverse of this. Okay. So we'll discuss how to solve matrix equations a bit later, but this is how we solve it. This is called direct method. No? This will be done in one shot, but of course, computation of A inverse will take time. Okay, but we focus on iterative method. So Jacobi method will be what? So we already have solved for Laplace, no? This one. So old values of phi's, take the average. So I'm basically solving phi I comma j equal to, just take the right hand side and its average, and there will be a 1/4 here as well. 1/4 coming here. That's what we have it here, 1/4. Okay, so this is for the solution. This will be phi. Okay, but I do not have a solution. I am doing iteratively. So I start with well, boundary condition is fixed already at all the walls. But inside I choose some random values or guess values and iterate. Okay, and then we converge reasonably quickly to the solution. So this solution is for source. So this is source, which is exponential minus 20 r squared. So it is smoothly varying, but it is peaking in the center. Okay, 0, -1 to 1. So it's a 2x2 box. There's a source sitting, but source is not a point source. It's a sphere. Well, no, sorry, disk. But disk is, well, it's not really a disk, sorry. It is diffused charge, peaking in the center. Okay, so it's peaking in the center like that. Now, this is a potential. So this source will create a potential phi, and what I solved, I'm displaying it in density plot. Okay, so potential will be highest in the middle, and it again decreases. Okay, so this is by Jacobi method. We can apply other methods, identical as what I discussed for Laplace equation. We had for Laplace equation, we had Gauss-Seidel, red-black Gauss-Seidel. You can apply all of them. Okay, and we basically get the solution. Okay, so I will not repeat them. Can just do it yourself. Okay, so this Laplace Poisson equation discussion is very brief because it's very, very similar to what we do for Laplace equation.